ଆପଣ ଶୁଣୁଛନ୍ତି 90.4 SOA Radio.
Hey everyone, this is RJ Akriti and you are listening 90.4 SOA Radio. आपण समस्तଙ୍କୁ स्वागत करछि आज रे विशेष उपस्थापना को। फ्रेंड्स, महाकाश बा स्पेस को नहीं बहुत जण स्वप्न देखंती एवं किछि जण या को साकार मध्यम करिथांती। तेबे आज रो ही विशेष आलोचना रे हम सहित सोआ इंग्लिश कैफे रो तीन जण स्टूडेंट्स जोड़ी हेछंती जो माने हमकु ह्यूमन स्पेस फ्लाइट विषय रे किछि जरूरी सूचना जणैबे। तेबे चलंतु आज रो अतिथि मानकु स्वागत करिबा एवं तांको सहित कथा बा ह्यूमन स्पेस फ्लाइट विषय रे।
People say that sky is the limit, but humans have proved that they can go beyond the horizon. Hello everyone, my name is Devanshu Singh and I'm a co-member at the SOA English Cafe.
Hello everyone, my name is Jibitesh Kumar Mishra and I'm a co-member of SOA English Cafe.
Hi everyone, my name is Arpit Mishra and I am a core member of SOA English Cafe.
Let's dive into the mid-20th century, the Cold War between two superpowers of the world, USA and USSR. This tension extended beyond Earth to the space. Marking that, let's talk about 1957, the launch of the first artificial satellite, Sputnik 1. So, do you know it was just weighing 58 kilograms to 83 kilograms approximately, and still it was moving at a speed of 29,000 kilometers per hour. Can you just imagine that? That was so amazing. And it was completing an orbit around the Earth every 96 minutes. Though it just lasted in the space for almost 3 months or something, and eventually burnt out while it was entering to the Earth's atmosphere in January 1958. Talking about that, let's dive into the India's past, is ISRO, how it started and how they get into the space. Jibitesh, would you like to continue that?
Okay, let's move to the past of the ISRO about the Indian satellites. So let's start about the satellite launch vehicle. So the first satellite launch vehicle was able to carry only 40 kg. That was SLV. Then some experiment and innovation came and one new launch vehicle introduced, that was ASLV, that is Augmented Satellite Launch Vehicle. So after that there was many problems, like we want to move to the synchronous. So let's start with the history of ISRO. So I will start with the launch vehicle history. So the first launch vehicle was SLV, that was Satellite Launch Vehicle. So it was able to carry only 40 kg to the LEO, that is Lower Earth Orbit. The innovation came and many experiments occurred, and the next launch vehicle was ASLV, that was Augmented Satellite Launch Vehicle, and it was able to carry 150 kg to the Lower Earth Orbit. But there was many problems, like we need to move to the synchronous solar orbit. So scientists came with many innovation and many experiment, and then we came up with PSLV that we are using right now, that is Polar Satellite Launch Vehicle, and it is able to carry 1750 kg, and that is how the innovation of the launch vehicle occur in ISRO. So let's move to the satellite and more about the history part and some of the future part about how ISRO grow and what is the perspective of not only in ISRO, about the whole world. So I would like to pass the mic to the Arpit. Can you explain me more about some sort of future part?
So let's talk about the future advancements that may or may not happen in space technologies. Coming back to the point of satellites and launch vehicles, we are theorizing about the fact that we can use warp drives as well as quantum drives. Now, what are those? Warp drives technically means that we go at a warp speed, like a percentage of light speed. Why does it matter to go at percentage of light speed? Because it's fast, really fast. The light speed is 3 lakh meter per second square, and if at a fraction if we move, we can cover the earth in an instant. So if we do it in an actual space scenario, it would be very fruitful. But why don't you do it? Challenges are there. Number one, when we try to implement warp space drives, we try to also know about the fact what will happen to the humans inside it. Warp drives will actually have a very negative impact on human beings at the present condition. Hibernation is a possibility, but it wouldn't matter, because when you are stretched across space and time, anything that happens inside and outside the space is typically the same. You are stressed out. And if you remember black holes, you wouldn't want to dare to go into that because black holes stretch you out completely. One thing that I saw in a sci-fi series is that they used event horizon of the black hole to escape from the enemies. Why? Because it dilated the time. So for them it was a few seconds, but for the actual enemies it was days and days. So is it really possible? Only in one way, warp bubble. What do you mean by warp bubble? Warp bubble technically means that we create a bubble outside the spaceship. What happens when we create it? We stretch the space and time increasingly and very efficiently. The spaceship doesn't move inside the bubble, but the bubble actually takes it through the space. So it has a significant speed. But why can't we do that too? Because we haven't mastered the space and time clearly. Now, moving on to the past, I want to hear from Devanshu what would have happened if in the past warp drives would have been created.
Well, yeah, you are absolutely correct. The thing that Jibitesh mentioned earlier, that now we are able to carry over 1000 kilograms of weight to the space, and you also mentioned the moving of vehicles at the speed of light in the space, right? So that is the major thing. But if you go into the past and look into the other launches besides Sputnik 1, that was just weighing 83 kilograms. The first thing they did was sending a living creature into the space in Sputnik 2, again in 1957 in November, and they were increasing the time of revolving around the Earth, right? The first Sputnik 1, it was revolving around the Earth taking just 96 minutes or something, but Sputnik 2 took 103 minutes to take a complete orbit around the Earth. Yet the USSR didn't stop here by just sending Laika to space. They set another great milestone for the world by sending Yuri Gagarin to the space in Vostok 1 in 1961. This was something, a really proud moment for not just for Russia but the whole world, and gave a hope to people that now even they can go and travel in the space. But yeah, obviously this was not something acceptable by the Americans, and John F. Kennedy, the president of USA at that time, decided that they should also launch a space program where they can send humans to the moon and also bring them back safely. So yeah, it was the Apollo program where Neil Armstrong and Buzz Aldrin stepped on the moon in 1969. Yeah, and that was again one of the greatest milestone in the history of space, right? Now let's diving into some of the present situation of going into the space. I would like to hear some of the points by Jibitesh.
So starting from India, then I will move to some of the private agencies. So let's start with the India perspective. So I would start with Chandrayaan. So it has started from Chandrayaan 1 to Chandrayaan 3. So Chandrayaan 1 was launched in 2008, then came Chandrayaan 2, that was in 2019. So both become failure because of some technical error, but no worries, Chandrayaan 3 was a successful mission for us. Let me explain some of the Chandrayaan 3 parts. So it was having 3 parts total. So the first part was lander, then was rover, and the third part was propulsion module. So the lander was Vikram and the rover was Pragyan and the propulsion module was lunar orbit. That was about the 2 parts. The most extreme part was about the propulsion module. So it was the lunar orbit. So just imagine observing Earth as an exoplanet and finding the habitable, like you are observing Earth as an exoplanet and you are in lunar orbit. So like this process is called spectropolarimetry. So like you are in moon and you are observing Earth as an exoplanet. So by this you can detect is there like habitable or life in Earth or not, because you are imagining Earth as an exoplanet. So this is what spectropolarimetry says about. And basically spectropolarimetry is a function of light as a function of wavelength. So this was whole about the Chandrayaan 3. So this is how the space agencies are doing collaboration from government agencies to the private agencies. So this is how the present scenarios are working.
But I have a question over here.
Yeah.
You just mentioned, and yeah, we did see that video that she just loves samosa, and
Yeah.
she also took Lord Ganesha with her to the space. But I guess Arpit, when we were discussing, you once told me that there are some set of rules and regulations about taking a diet
Yeah.
in the space, right? Would you please like to explain that?
Of course. So some of the rules that they have to follow is that number one, they have to limit the weight of each meal that they have. Number two, if food contains water, what happens is that food gets contaminated. Food has fungus over it. So okay. So what NASA does is that NASA dehydrates the food entirely.
Okay.
So and it seals it. So you can't eat those dehydrated foods. You have to use some droplets of water to rehydrate it and then eat. Of course, it's very tasteless, but it's necessary for survival, right? And according to official records of NASA, a current meal has to be around 0.63 kg. Okay. So it restricts, the NASA clearly restricts what type of food you eat so that you do not have stomach pain, you do not have illness or any type of conditions. Because of course, the toiletry situations in ISS, of course. And it also regulates the weight because according to the weight, they have to use the fuel. So even for a small banana, they have to use 1 kilogram extra fuel, which is very high because it's not normal petrol. It's actually a lot more expensive.
Yeah, so when you actually talk about being in the space, it's really it's amazing and awful at the same time, doing everything on a daily basis over there. But so I would like to take our audience to the past once again. How was the first space work in 1965 by USSR? Because obviously when John F. Kennedy stated that they will be conducting a mission of sending humans to the moon, so obviously they didn't stop at just sending Yuri Gagarin for 108 minutes to the space. They also sent the Voskhod 2, which was boarded by Alexei Leonov in 1965, and he walked in the space for about 12 minutes, and that was again a great milestone, right? So yeah, now I'd like to hear from Jibitesh. What are your points on this thing?
Yeah, talking about the human space flight, presently talking about India's perspective, we have our Gaganyaan mission that is going to launch very soon. Our ex-director, that was Dr. S. Somnath, has planned a very big mission about Gaganyaan mission. Soon from India, we are sending astronauts to space. And talking about NASA perspective, we are having Artemis 2 mission, and we are again going back to moon after Neil Armstrong, that Apollo mission. We are again going back to moon. So this is how the human space flight is growing, the evolution is growing. And also if I talk about the finance perspective, we are also having very drop of price in the aerospace sector because of we are able to use the rocket again and again. Beforehand, what we are doing in the past, like we are using a rocket, and after it is done, we are dropping it in the big ocean.
Yes.
So we can't use it again. But now we are able to use it again and again because of the first thing that Elon Musk challenged, that is about the reusable rocket.
Of course, you are right, Jibitesh. So coming to the point of exoplanets, one of the nearest exoplanets that we have is Mars. Now Mars is a very interesting planet because it resembles kind of like Earth. It has a year span of around 687 days. So 1 year on Mars is actually 2 years on Earth. So you will age very less. Okay, so you do not have to use Botox and everything.
That's really nice.
Yeah. But the school days would be very much larger. So it would be around 48 hours, which would be not terrific. And about the time of how will we reach Mars? Of course, reaching Mars is a technologically advanced topic because we have to also consider the well-being of humans. For instance, if I am going to Mars, if I am sitting on the iron rocket, inside the rocket, and they have launched me from Earth to Mars, it would take time based upon the number of energy quantity that we have inside the Earth, as well as how much every energy quantity would actually affect our well-being. Okay, so like in Interstellar, you would have seen that the people use hibernation pods, right?
Yes.
So hibernation pods can be used to extend your survival by making yourself so comfortable in the sleep of ice chambers that you wake up after 6 months or so, and half of the journey would be over by then. You will also eat less,
Yes.
okay, and you will be not slim, but your fat consistency will obviously decrease. So if you want to lose weight, so just go to Mars. But apart from the jokes, going Mars is actually difficult because from Earth to Mars it's a very large distance. So what are you trying to do? As Jibitesh said, we're trying to send Artemis mission to the moon. What will you do in the Artemis mission? Now, one of the future objectives of the Artemis mission is to have a base on the moon and extract resources from the moon. Now, moon has a ton of resource, okay, and it's worth billions and trillions. And if we use those resources which are not from Earth, we actually use the resources of the Earth in the people's development, and we use the moon's resources to enhance our spaceship's abilities.
So I think there would be a possibility when there must be some pilot in a spaceship saying, "This is your captain speaking, and yeah, we will be going to this planet or something, and please be ready for the launch." Yeah, that's completely amazing. But yeah, I also want to know from both of you, since you know so much about space. Obviously, before going to some particular place, we must know the location, right? So the NASA has already developed many type of equipments, and also the satellite Hubble's telescope. It's something really great, and we are able to locate so many planets even beyond the solar system. So are there any future missions, and what is about to be done with the Hubble's telescope later on?
Okay, so basically in the past and also till now, we were seeing some Hubble Space Telescope, but you have heard about James Webb Telescope. This is the largest big telescope that we are using right now, and it is using infrared ray. Okay, so because of James Webb Telescope, we are able to see exosolar planets and many other planets like Proxima Centauri b. The many you can. The name are undefined, many planets are there. So that is how the telescopes now, after James Webb Telescope, many other telescopes will come, and like Albert Einstein told, the universe is expanding.
Yeah.
So you are seeing something when the light is entering. That is why light year, you have seen 200 light years. What does that light year mean? To reach the light, it is taking 200 light years. So suppose someone space a light from Mars to you, so not Mars, any further planet, any planet which is very far from you, someone like sends a light,
Okay.
and that light will reach to you, like that person dies, and that light is reaching to Earth. What difference can it be made so that it can cross? Like the main thing that is required is the propulsion system, right? If it can be made like more advanced, then it can go far behind. So can you explain more about the propulsion system?
Actually, I would like to just state one point regarding the propulsion system. The NASA and even the other space organizations are trying to create some kind of momentum in the Earth itself. Like what they are doing is they are attaching the particular equipment of the satellite or any launch vehicle to a bar, a really big bar. I'm just showing this. And they just try to get a momentum in a circular manner, and then they throw it outside, so it gets a force, right? Before Arpit answers anything, I would actually like to add a point that how physics is helping or going to help in the future to send the satellites and other launch vehicles to the space. So what we use is we use some kind of propulsion liquid to launch, right? But what the scientists and engineers are right now planning is they are trying to create some kind of momentum first in a circular manner, and then throw it outside the Earth, so it gives some kind of force, and it's easier to launch because most of the fuel is wasted at the time of launching, right? That is the science behind it. But yes, Arpit, I would actually like to hear from you the question asked by Jibitesh.
Of course. So the question asked by Jibitesh was based upon the fact that why cannot we create wormholes and travel through it? Because it would be much easier for us humans. It would also not affect our health. The fact is that to create wormhole, we need enormous amount of energy, literally enormous. And instability is the key that we cannot move forward right now. The major part of wormhole is that it continuously collapses under the gravity of its own mass. So if you just circle the space around along with the time fabric, what happens is that time slows down, space collapses. What it forms is it tries to form a singularity between each and every point. So going through it would be really very difficult. The fact that about black holes, as Jibitesh said, is that if we go at the point of infinity, in the point of the singularity, we would be crushed. There will be no information of our soul, body, and etc. So what happens is that the first point is that it continuously collapses under the gravity of its own space and time. Second point, continuously collapsation of the space and time would also mean that you are continuously aging as well as your age is continuously decreasing.
Yeah, so that was a really insightful discussion. I would say we have been talking about a lot of technological advancements since the past, from the 1970s, since the space race ended. And we talked about the black hole, wormhole, how people are going to survive in the space after some years, probably. I hope we would be alive at that time. And for sure, even ISRO is doing a lot of things for that. But for the technological terms, I would really like to pass on the mic to Jibitesh and Arpit.
Okay, so as we came to lots of discussion about especially the human space flight, also we have added many cosmology aspects. So let's come to an end. Like, we have discussed many things about the past, like Devanshu explained many things about the past. I have gone through many of the present topics, and the Arpit has explained many things about the future perspective. So that is how this whole spacecraft mission, the space flight, we are seeing many NASA, SpaceX, many ISRO's mission, ESA mission, many things we are seeing. So exactly right, few days ago, Google has launched his own satellite, that is the FireSat satellite, because to handle the wildfire. So you can see everyone is coming to the aerospace industry. So that's the eagerness that everyone should have, because we are living in an earth and there is many things far behind the earth. So that's it. Now let's move to Arpit, what he wants to conclude about this whole discussion. Over to you, Arpit.
Of course. So I would like to just add one point, that if curiosity has made humans reach this particular point, then technology and evolution of our own society and our own technologies will help us to make us reach further beyond the horizon, right? So if we know the infinity, we can do the infinity. So thank you very much.
And thanks to the audience for joining us today to know about the space, the entire timeline starting from the very 1960s till now. And also we got to know a lot about the future, the technological advancements that we are going to see. And again, a big thanks to the SOA Radio community as well as the SOA English Cafe members to be here, and we got to know about a lot of things. So guys, thank you so much.
So friends, आजिर आमर विशेष उपस्थापना थिला ह्यूमन स्पेस फ्लाइट को नहीं, जोथिपाई आम सहित सोआ इंग्लिश कैफे रो 3 जण स्टूडेंट्स जोड़ी होते। मु आशा करुछि आमर अतिथि माने आपण मानक पाखरे खूब सुंदर तथ्य सब पहुँचे पारिथिबे। तेबे आज तो समय हो गलानी, मते विदाय दियंतु। मु पुणी थरे आपण मानक पई नै आसीबी आउ एक नुआ अध्याय। से पर्यंत सुनुथांतु 90.4 सोआ रेडियो।
आपण सुनुछंती 90.4 सोआ रेडियो।